So they outputted s.db. So this is the database table schema that it creates to put in all the S-trace data. I know SQL. Nothing. Did you log? Oh, okay. My fault. It actually only knows the PID if you use the -f option, which I didn't show earlier. But -f allows you to follow an application, and if that application starts other children, it logs PID. Otherwise, it just logs parent as the name of the PID for the parent, because it doesn't know. Strace doesn't actually tell us what the name of the PID is. So having it in a SQL database makes it easy to see what it's doing and how long certain things are taking. If you look at the schema again, one of the things it logs is the duration of each system call. So we can take a look at something. So it's got, unfortunately, SQL considers null to be greater than an actual value, but so this one took 23 seconds to finish, but that's fairly normal because it was just waiting for a to actually receive a connection. But this read call took 7.7 seconds to complete. You can see here it's reading off file descriptor 11, so it might be possible to see what file descriptor 11 is by looking for a system call that returned 11 as a value. This field rent gives you the return value of every system call that was successfully captured. Okay, so file descriptor 11 was it opening /dev/random in order to generate its random numbers. But we see here that it's taking almost 8 seconds to read 1 byte from this file. So on Linux, dev random will actually stall your process of reading from it if there's not enough random entropy in the kernel to actually give you a true random number. So in an application like the one that I'm showing you, this stupid dice rolling app, you might not need true random numbers, so using dev random here is not such a great choice, but it's pretty good for demonstrating the kind of things that you see out of strace. You know, you're seeing reading a small amount of data but very slow. In a sort of real-world example, remote service, you'll see a long-running read. It's fairly easy to see which system calls take a long amount of time by using this tool, and finding out where that source is coming from is very easy with this tool as well. Otherwise, I mean, you can have, I have strace files from our last debugging that are a couple of gigabytes big, and the grep was pretty much my only tool before I had this for finding it, and it was very slow work, right? I would grep looking for long-running durations and doing a range number search in a regular expression is not the easiest thing to do. Once I found, oh, that one's slow, which file descriptor was it? And I have to grep for the file descriptor, right? And grep. Each one of those greps is getting progressively slower. It can be if you've got huge data, because it's not really the tool that's slow, it's your workflow is getting slow. You're constantly having to write a new regex, right? Go back to the data. This is a little bit more interactive.
SQL query works faster than grep on the text file. the parent and children only bits, and if it is a thread, not a bit, how it can be identified?
Yeah, I'm not sure what the strace output looks like for a threaded application. I mean, if anything was outputted, it would be in this table. Fortunately, our app is not threaded. So.
It may happen.
One day. Okay, so the next tool we're going to take a look at is PS. Running PS with the -L command can give you an extra useful piece of information, which is the wait channel. But we'll talk about that after we talk about process state. It gives you the state of each process. Usually it's a single character code. There are longer ones where it gives you a little bit more information, and it also gives you this idea of the wait channel. Processes in Linux will run through these states during its lifetime. These two, the one I highlighted red is my least favorite state. This one is particularly awful as well, but this one usually is a result of maybe a bug in your application not catching its children properly. But this one indicates really bad I/O happening. And we've seen this happen in our production environment where we have just a huge number of things trying to read off NFS at the same time. It actually will lock inside of the kernel, which sucks. But when a process is in D state, it's essentially stuck inside the kernel doing an operation, and there's nothing you can do about it until that operation completes. Regular I/O puts you in this S state, interruptible sleep, where the kernel is just able to say, stop here, wait for me, when I'm done, I'll bring you back awake. But D is really a hard lock. So the other useful information you get out of PS is this function, the wait channel. The wait channel is actually the name of the kernel function that the kernel is executing on your behalf that you're currently waiting on. It truncates it here. You are able to tell PS to give you the full one. But what wait channel allows you to see is a little bit deeper into what's actually happening inside your application in terms of the kernel side. So if you think about, this is sort of a naive picture of what your kernel looks like, but you have your system call interface on the top, and this is what strace is able to tell you. Below the system call interface, you have subsystems like the file system and the socket domains. Below the file system, there's the different types of devices like SCSI or the virtual file systems. Below SCSI, you actually have your device drivers. So in each of these areas inside the kernel, the PS will show you sort of where it is at via the wait channel, via the actual name of the actual function that the kernel is running. So, like I said, it gives you an idea of exactly where you're stuck. There's sort of two places to find out what the wait channel means. First is just by the name of the function. If you're stuck on SCSI error handler, it's probably related to something with SCSI, right? Or you can grab the kernel source, which is not that bad, really. The kernel functions are very well documented, I think, and the code's not that scary. So in order to help with that, I have another SQLite generating tool called procmon. And procmon periodically checks the status of all the processes running on your machine, logs into SQLite along with the current wait channel it's waiting on, the process state, and it also gives some idea of its memory usage. Which will give us a